Welcome to the second video tutorial in our series on optimizing transcranial electrical stimulation using software tools. In this video, we'll be focusing on the Zeffiro Interface, a software package that allow you model and optimize electrode configurations for TES. The Zeffiro Interface is a software package developed by a team of researchers and mathematicians to advance the research of neurostimulation. The software has been designed for modeling finite element simulations of various types, ranging from tomographic microwave radar measurements of asteroids, which is beyond the scope of this tutorial, to optimizing electrode placements for brain stimulation. The installation process is described in detail on the main page of the app repository, which you can access by following the link in the video description. Before you begin, make sure you have MATLAB installed, along with the required set of toolboxes. Additionally, you will need to have Git installed on your computer. Git is a version control system, which is used to fetch the source code of the app to your desktop. In the terminal, navigate to the directory where you want to install the Zeffiro Interface and execute the command suggested on the main page. It will download the source code along with its dependencies into a new local directory. This process may take a while and depends on your network speed. Once the installation is successful, open MATLAB and navigate to the newly created directory with the project code. Then execute the Zeffiro_interface command. When the app starts, you will be ready to start exploring its features and functionalities. Before we dive into the details, please note that Zeffiro Interface is constantly evolving and may have changed since the creation of this tutorial. We encourage you to visit the wiki page of the repository for more detailed and updated information about the windows and tools we will cover in this video. As you can see, after starting the app, it opens multiple windows, which we will cover one by one. These windows provide the main set of tools you will be interacting with most of the time. Let's start with the menu tool. Here you can see a set of different options allowing you to control the app, such as saving the project, exporting and importing data, and getting access to other tools. This is the main window of the app, so if you want to exit the Zeffiro Interface, it's enough to close this window. In order to demonstrate the interaction with other tools, we need to open the multi-compartment head demo project provided in the repository. A separate window with the progress bar will be opened, indicating the progress of the current task. After the project has loaded, you can see the segmentation tool here on the left. It contains different head compartments and allows you to toggle them on and off, view and adjust their conductivity parameters, and control their visibility. The electrode controls can be revealed by clicking the Toggle Controls button. Let's move on to the Mesh Visualization tool. It focuses on configuring the 3D mesh representation of the head model, generated during the segmentation process. It allows to manipulate various visualization parameters, such as clipping planes, orientations, and locations, to examine the model from different perspectives. For now, let's leave it with the default configs, click the Visualize Surfaces button, and move to the next tool. The Figure tool is designed for visualizing the 3D head model. It offers various sliders and controls that allow you to adjust the properties of the visualization in real time. Here you can visually inspect the brain reconstruction and have a closer look at interesting regions. Feel free to experiment with different sliders and see how they change the visualization. Remember that you can uncheck the visible toggle for the top layers of the model and click the Visualize Surfaces button again to have a better view on deeper brain regions. Also, you can use the Explode parameter to inspect the quality of the reconstruction of certain areas. Now that you have a foundational understanding of the Zeffiro Interface, we encourage you to explore the software further and practice using the demo project. Since the app is built upon the MATLAB platform, having prior experience with MATLAB can help understand the underlying processes and troubleshoot potential issues. In case of any technical problems, You can start by first checking the error messages in the command window and reading the software's wiki pages. Then try to search for similar issues in GitHub. If you can't find an appropriate solution, consider reporting the error on the GitHub repository, where the developers can offer support and potentially address the problem in future updates. This tutorial is just the beginning of your journey in optimizing TES electrode placements. Remember that learning and mastering any new software takes time and practice, so stay persistent, seek help when needed, and contribute to the community by reporting errors and sharing your experiences. In this tutorial, we introduced the Zeffiro Interface software and demonstrated how to install it and load the demo project. We had a glance at the main windows within the software, covering the segmentation tool, mesh visualization tool, and figure tool. Thank you for watching. Good luck with your exploration, and we will see you in the next tutorial.